Students, today we are going to discuss about the Habers process, which is very important for ICSE class 10, and it is from the chapter Study of Compounds from ICSE class 10. Now, what is Habers process? Now, the process in which nitrogen reacts with hydrogen to form ammonia, that is the Habers process, and it is an industrial process. It is an industrial process for the preparation of ammonia. It is an industrial process for the preparation of ammonia. Now, how we can prepare this ammonia? Now, we have to take the raw materials like hydrogen and nitrogen. Now, that hydrogen we can easily get from the Bosch process in the preparation of hydrogen, that means from water gas, and also we can get from the natural gases. Okay, it is very abundant in the natural gas, so we can get hydrogen from the water gas, that means in Bosch process, or from natural gases. Okay, now what is the method here to prepare the ammonia? Here, 1 volume of nitrogen reacts with 3 volume of hydrogen to form 2 volume of ammonia. This is the Habers process. That means the ratio of the volume of nitrogen and hydrogen should be 1:3. Ratio of hydrogen and nitrogen should be 1:3. Okay. Now this reaction is actually an exothermic reaction where we will get the heat. Okay, heat will be evolved from this reaction around 22,400 calorie heat will be evolved from here, and this reaction is exothermic reaction, also reversible reaction. Okay, and this reaction undergoes with the decrease in the, that means it proceeds with the decrease in the volume. So what is this reaction actually? When hydrogen, 1 volume of hydrogen reacts with 3 volume of nitrogen, 3 volume of hydrogen reacts with 1 volume of nitrogen. By reversible process, it will form 2 volume of ammonia with heat. This much heat it will generate. So this reaction is exothermic reaction. Hope you can getting exothermic. This reaction is exothermic reaction. It is an exothermic reaction. Also this reaction is reversible reaction, and it proceeds with decrease in volume. Clear? Now, to get, as it is exothermic reaction, to get maximum yield of the ammonia from this reaction, we have to follow some conditions, and without that condition we cannot get much amount of ammonia in the reaction mixture, in the product. Okay, so we have to follow some conditions. Those conditions we will discuss now. Okay, to do proper exothermic reaction, as it is exothermic reaction, we have to follow some conditions also for reversible, and as it is undergoes a decrease in volume, so we have to follow some condition. That condition we will discuss now only. Okay, let's see what are the conditions that we have to follow to make it reaction properly. Okay, so what are the conditions we have to follow? The first condition is the temperature. The temperature we have to control. Okay, temperature. The first condition is the temperature. As it is an exothermic reaction, so to make good yield, we have to lower the temperature. We cannot heat in very high temperature. Okay, so that temperature is around 450 to 500 degrees centigrade. Around this temperature we have to control the reaction. However, we have seen if the temperature is less than 450, then the reaction slows down. Okay, if the temperature is less than 450, and also if the temperature is more than 500 degrees centigrade, then the rate of the reaction decreases. So what we have to do? We have to control the reaction within 450 to 500 degrees centigrade temperature. Okay, this temperature is called optimum temperature. Optimum temperature for Habers process. Optimum temperature. With this range we have to control the reaction, not less than 450, not more than 500 degrees centigrade. Okay, now next is the catalyst. We all know that to speed up our reaction, to increase the rate of a reaction, we need catalyst, and catalyst will take part in the reaction and it will increase the rate of the reaction, and after that the catalyst will remain unchanged. And here we have to also use a catalyst. That catalyst is finely divided iron, finely divided Fe. Okay, this catalyst we have to use, and also with that a promoter we have to use that will increase the rate of work of the catalyst. That is also promoter, which is molybdenum. We have to use a promoter, that is molybdenum, and after that the rate of the reaction will increase. Okay, now better catalyst we can use instead of this Fe, that is ferric oxide. Better catalyst, we can use better catalyst. That means if you use instead of Fe, if you use Fe2O3, that means ferric oxide, then the rate of the reaction will increase. So it is better catalyst. And when we are using ferric oxide, in that case we have to use two promoter, that is 1% of potassium oxide with 3% of aluminum oxide as promoter. So when we are using the catalyst is ferric oxide, in that case we have to use these two promoters. Okay, so these are the two factors that one we have to follow for this reaction, for Haber process: temperature and catalyst. Okay, now the next thing is the pressure. Pressure is another condition we have to follow. Now as the reaction proceeds with lowering in the volume, we have seen, and it is exothermic reaction, so we have to maintain a high temperature for this reaction. We have to maintain a high temperature around 200 atmosphere to 900 atmosphere temperature. Okay, so that the gas is compressed properly as this reaction proceeds with increase in the volume. So this one we have to follow. Temperature should be around 200 atmosphere to 900 atmosphere pressure. Pressure should be around 200 to 900 atmosphere. Okay, so this is the necessary conditions of the Haber process. Now another condition we have to see the impurities. If the gas can contain raw materials, we have to see another condition, impurities. The gas that is in the raw materials like hydrogen and nitrogen can contain some impurities like carbon monoxide, carbon dioxide. Okay, and that will hamper the reaction, that will decrease the rate of the reaction, that will also will not speed up the reaction. Okay, we will get less yield in that reaction if some impurities are there like carbon monoxide, carbon dioxide. Okay, so what we have to do, we have to take a pure dry hydrogen and pure dry nitrogen. Okay, so no impurities will be there. Okay, pure dry nitrogen and pure dry hydrogen we have to take. Okay, so maintaining this all condition, if we want, now we will see a total flowchart of this reaction. What is flowchart? That means what we have done actually here in the total video, that one I will tell you. Okay, that we have taken nitrogen, 1 volume of nitrogen and 3 volume of hydrogen, and after that we will compress. Okay, we will compress. So here one compressor. Okay, so from this compressor will be added with a catalyst chamber, we have passed nitrogen, 1 volume of nitrogen and 3 volume of hydrogen in a compressor, and after that we have compressed the mixture of gas and we have got a mixture of nitrogen and hydrogen. Now this mixture of nitrogen and hydrogen, it is here in this catalyst chamber. Okay, now from the catalyst chamber we have got a ammonia we have got, that means after the reaction ammonia we have got, and with it some unreacted nitrogen and hydrogen. Okay, and that is passed on a condenser. Okay, now this condenser contains some ammonia, pure ammonia with nitrogen and hydrogen. Now to separate ammonia from this mixture nitrogen and hydrogen, we have to liquefy this gas. So liquefaction. So after liquefaction we have got ammonia. Or you can go for another process, that means you can dissolve that ammonia in water, and ammonia is very much soluble in water, so it will get hydroxide of ammonia, that means ammonium hydroxide, and from there you can easily separate. Okay, so what we have done, we have taken the mixture of ammonia, nitrogen and hydrogen in condenser. Okay, that is condenser. So now the unreacted nitrogen, what will happen with the unreacted nitrogen and hydrogen? That can be again used in the compressor. So the unreacted nitrogen and hydrogen can be again used in a compressor, and that can be again taken in the condenser. After that we can again get ammonia. So this is the actually flow chart I want to tell you. So this is the total process. So I think you have understood. So to get more videos, you have to subscribe my channel and you have to comment in the comment box what are the problem is there. So, and also please hit the bell icon. Thank you.